What kind of mysterious force that limits the Earth can't have mountains over 10,000 meters high? You know, in the vast solar system, almost all mountains on rocky planets are all over the 10,000 meter critical point. For example, Olympus Mons on Mars is 21,900 meters. The mountain of Ceres, Vesta, reaches the sky. 22,500 meters is equivalent to. But why are the mountains on the larger Earth are so short? We always regard Mount Komalangma's height of 8,848 meters as a legend, but few people know the secret of this number. It was actually measured on the Qinghai Tibet Plateau, on the shoulders of the giant. If we calculate the height directly from the foot to the top, the true height of Mount Everest is only 3,484 meters. In contrast, Hawaii's Mauna Loa volcano, the vertical distance from the seafloor to the top, is more than 10,000 meters. Only 90% of the mountain is submerged in the deep sea, which allows Mount Komalangma to keep its title of the highest. What's more surprising is that, if measured by the distance from the center of the Earth, the Chimborazo in Ecuador is more than 2,000 meters higher than Mount Komalangma. In fact, in the scientific community, adopts the altitude measurement method, is to use the average sea level as the zero altitude, is precisely because the Earth itself, there is an insurmountable height ceiling. The core constraint behind this is the strong gravity of the Earth, as the largest rocky planet in the solar system. Earth's gravity puts mountains under enormous pressure. The compressive strength of rock is limited when the height of the mountain approaches the bottom. The rocks will be like crushed building blocks and break and collapse due to the weight. It is calculated that the pressure at the bottom is close to the critical value of rock strength. If the height exceeds 10,000 meters, the entire mountain will deform plastically due to its own weight and eventually collapse. In addition to the influence of gravity and rock strength, the active geological activities of the Earth also continuously lower the height of the mountain. Erosion, glacial erosion, earthquakes, just like a never-ending carving knife, continually reducing the height of the mountain. More importantly, the Earth's crust is not a solid plate. The crust of the continent is only 40 kilometers thick. The crust always floats on the mantle, just like a wooden board floating on water. The higher the mountain, the more the crust is pressed into the mantle. This crustal equilibrium effect will continuously consume the height of the mountain. Compared to other planets, Mars' gravity is only 1/3 of Earth's, which makes the rocks bear less pressure. Mount Olympus can last for over 2 billion years and continue to accumulate on a white dwarf with stronger gravity. The highest mountain may be less than 1 meter. Geologists speculate that Mount Komalangma a million years ago may have reached a height of over 12,000 meters, but under the continuous action of gravity and geological activity, it has now dropped to 8,848 meters. Although, Mount Komalangma is still growing at a rate of. But to break through the 10,000 meter mark, it is still an unreachable dream.